Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 1.7 notes. Alright, so today we are looking at solving absolute value equations and inequalities. So, my essential question for today is how do I solve equations and inequalities that contain absolute value? Symbols. Alright, so that's what we're looking at today. We're looking at these equations and inequalities that deal with these absolute value symbols. So if you remember, absolute value symbols are these guys that stand straight up. And remember that whatever is inside the absolute value brackets make it positive. So big thing right there. Everything that comes out of an absolute value is positive. Okay, so if I look here at absolute value equations, we have this guy. The absolute value of x equals 5. So you have to ask yourself, what could possibly go in for x that if you take the absolute value of, you get 5 out? Okay, so either you could have an answer of 5, the absolute value of 5 is equal to 5, or you could have the absolute value of negative 5, which is also 5. So notice here that this guy has two solutions. So every single time we are going to have two solutions when we have these guys. All right, so if I look at this first example, the thing that we do to split up absolute value symbols is we accept the positive and the negative answer. Okay, so what I'm going to do is I like to do this. I like to draw a couple branches out because I'm going to have two equations. I'm going to have x minus 2 is equal to 5, and I have x minus 2 is equal to negative 5. Okay, so now if I look to solve these two equations, I know that we can all do this. We add 2 to both sides, so I get x is equal to 7. And here, if I add 2 to both sides, I get x is equal to negative 3. Okay, so those are my two answers for this guy. If I look, and you can kind of check yourself here, if the absolute value of 7 minus 2, if I plug it in for x here, I get 7 minus 2 is the absolute value of 5, which gives me 5. And also I have the absolute value of 3. If I plug in this one, minus 2 is going to be the absolute value of negative 5, which also gives me 5. Okay, so absolute values, we're going to end up with two answers. Okay, so the main thing here is that you have to accept the positive and the negative. So before we broke it apart, so we broke it apart into these two things right here, we could do that because the absolute value is all by itself on that side. So now notice in example number 2, we got this negative 4 hanging out here. Okay, we have to get rid of that guy first before we break anything apart. So here, if I have that, now I'm going to still have the absolute value of 2x minus 5. Now that 4 and the negative 4 go is equal to 6. Now 2 plus 4 gives me 6. So now if I look, now I have the absolute value is all by itself. So now I can break this apart into 2x minus 5 equals 6. And 2x minus 5 is equal to negative 6. Notice I don't change anything on this left side. That 2x minus 5 comes here, and it comes on that right side. So you don't change anything there. You just change the 6 into the negative 6 in the last one. That's the only thing you change. So now I can go through and solve this guy. If I add 5, I get 2x is equal to 11. Now if I add 5 over here, add 5 over here, I get 2x is equal to negative 1. And notice here you're going to end up with some answers that aren't nice numbers. You're going to get some fractions. So if I divide by 2, I get x equals 11 halves. And if I divide by 2 here, I get x is equal to negative 1 over 2. Okay, so notice, break those guys apart. Okay, break them up into the positive 6 and that negative 6 here. And then go through and solve each one of those. So notice, every single one of these guys has two solutions, absolute values. All right, so that is the absolute value equations. Now let's look at some absolute value inequalities. Okay, so I have some things here about an and an or. Okay, so you can memorize here that less than or equal to is going to be and greater than or equal to is going to be or. Okay, but really the math is going to figure that out for you. Okay, so what we have to do here is first, just like the equations, isolate the absolute value term in the left side. So here first, before I do anything else, I got to get rid of this 3, so I'm going to add that 3 over. So now I have the absolute value of 2x plus 1 is greater than or equal to 9. So be careful there that I have greater than or equal to, not equal to. All right, and then here's kind of the part that gets people mixed up. So I break this apart again into the 2x plus 1 is greater than or equal to positive 9. And then next, I have 2x plus 1 is less than or equal to negative 9. So I want you all to write this down with me. Oh, where'd my star go? There, it's back. Here I have, when you accept the negative answer, you must switch the inequality. Okay, so this is just like when we had the equations yesterday. I mean, just the regular inequalities is that when we divided by a negative, remember that we had to go through and switch that sign. So this is the same thing. When you accept that negative option, you must switch that sign from a greater than to a less than here. Okay, so switch that guy around. Now you go through, just solve this guy just like the other way. So you subtract 1, subtract 1, subtract 1, subtract 1. I kind of like to do the same step to every one because that's just how I like to do it. So I have 2x is greater than or equal to 8, and I have 2x is less than or equal to negative 10. Okay. Now if I go through, I divide by 2, divide by 2, divide by 2, divide by 2. Okay. And I get x is greater than or equal to 4. Circle that guy, and I get x is less than or equal to, negative 5. Okay, so here's the part where it's going to tell you when I was talking about up here with this and this or. Okay, here's the part when you graph these guys. So if I have negative 5 over here and 4 over here, all right, if I graph this guy, I know that above the 4, I have a greater than or equal to, so that's going to be a closed in dot. And I know that all the numbers that are greater than or equal to 4 are to the right, and all the numbers that are less than or equal to negative 5 is also a closed dot, and those numbers are to the left. Okay, so here we looked and found these absolute value equations and inequalities. This main part here is that absolute value equations and inequalities have these two solutions. Okay, so every single one you have to break up to the positive answer and the negative answer and then solve. So please do me a favor and see what you can do on that worksheet, 1.7 worksheet. When I come back, we will talk about it and answer all the questions. Thank you. Have a good weekend.